Howdy guys, my name's John, and today we're going to be looking at how to modify single cycle data paths. The problem we're looking at right now is from PastExam1, problem number 6. So we'll just go ahead and get right into this. Alright, so we'll see that we'll be needing to add a new R-type instruction, LWE. Here's the opcode for it. And we'll see that LWE, or load word extended, adds the values stored in registers RS and RT together to form a memory address. Then the word at this address, RS plus RT, is loaded into register RD, and we'll want to keep all other instructions unchanged. Okay, so let's go ahead and just take a look at our MIP screen sheet, and we'll see that R-type instructions, they'll have an opcode, register RS, register RT, register RD. They'll have a shift amount and a function code. So if we go back over here, we'll see that here we have our opcode, register RS, RT, and RD. But we do not use our function code or our shift amount. Okay, so part A. So this is where we're going to be wanting to figure out what exactly we need to do to the data path to get this this instruction to run. So the easiest thing is to just take a look at this and notice that it is a variant of a load word instruction. And so right now we can just go ahead and just take a peek at how regular load word instructions work. Okay, so load word, Alright, so load word instructions, they write to register RT, and then they read from RS with a immediate, a 16-bit immediate shift amount in that address. Okay, so let's just go ahead and see how a regular load word works. So you start here with RS. You load RS from your registers, put that in your ALU, and then you take your 16-bit shift amount, run it through your sign extender, so now it's 32 bits, and then you're going to want to go through this ALU and load it in, or go through this mux and load it into your ALU. So then the ALU will add together RS and the 32 sign extended shift amount, and then that'll become your address that you read from memory. And then the word at that address is then pushed through that mux and put right into your write data. And what you'll be writing to is register RT right there. Okay, so that's how a basic load word instruction works on this single cycle data path. So how exactly can we get this to do what we want? So we know that instead of adding together RS and this immediate value, we're going to be wanting to add together RS and RT. So let's just go ahead and do that. So we start with RS and we put that in our ALU. And then we'll take RT and we'll put that value through this mux and into our ALU. And same way we did it before, we'll add those two values together, and that becomes our address. Okay, and so with that address, we take the data there, go through this mux, and just like before, put that into our write data. And what exactly are we writing to? We're going to be writing to RD, and then go to the mux, and that's it. So what did we do here? Really all we did was just take an instruction we already had and change the control signals so that instead of adding this immediate value with RS, we'll just be adding RT with RS. So we didn't really change the data path at all. We just changed the control signals. So now we can go and answer the questions over here on the side. So did we change the data path? No, we didn't. Let's see. Since LWE is similar to load word, all that needs to change is that we add RS plus RT instead of RS plus the immediate value. Right. And in order to add RS and RT, and instead of the immediate value, we just change ALU source from 1 to 0. Okay. So, did we add or expand any new control signals? No. They're all the same. Well, the control signals aren't the same, but we didn't add or change or expand any of them by making them larger. Okay, so part C. What is our registered destination value? Registered destination value, we're going to be wanting to write to RD, so that's going to be 1. ALU op. Okay, so let's take a look at our old lecture slides, and we'll see that for the regular load word instruction, ALU op is just 0, 0. And we did that before because load words don't use a function, and neither does this R-type instruction use a function. So we're just going to do the default load word operation in the ALU, which happens to be add. So that'll add together our values. Our ALU source, we've already said that this needs to be 0 instead of 1 like it was before. Our mem to reg value, this is going to be 1 because we're going to be wanting to read from the data. So register write. Are we writing to a register? Yes, we are writing to register RD. Register read. I think this here is a typo. That's supposed to be this is supposed to be for memory, so just ignore that one. Okay, and then branch, we don't branch at all, so that is 0. And then memory write, we're not writing to the memory, but we will be reading from the memory. So read memory, memory read is 1. Okay, and that's all you got to do for this problem. You don't have to change anything, you just have to change a couple of control signals around. Alright, thanks and gig 'em.